Hello students, in this presentation I will explain you the introduction to the D block elements. The overall presentation involves what is a D block element, a transition element, what is the general electronic configuration of these D block elements, and also the different properties shown by the D block elements. Myself, Dr. B. Anusha, working as a lecturer in chemistry in Silver Jubilee Government College, Autonomous, Kurnool. First of all, we will know about the chemistry of D block elements. In a periodic table, a block is nothing but a set of elements unified by the orbitals, their valence electrons or the vacancies lie. As we know, in the periodic table, each block is named after its characteristic orbital in which our differentiating electron or the valence electron entering, whether it is entering into the S block, that is S orbital called as a S block element. If it is entering into the P orbital, that is P block element, or if a differentiating electron enters into the D orbital of penultimate shell, that we call as a D block, which we are going to discuss now, and the F block elements in which the differentiating or valence electron will be entering into the F orbital of the anti-penultimate shell. In this, as we already told, we will know or explain you about the D block elements. Then what is a D block element? D block elements are nothing but these are the elements in the periodic table in which the differentiating electron enters into the D orbital of the penultimate shell. Then what is penultimate shell? Penultimate shell is the shell which is present before the valence shell. For example, if you consider these are the orbits of an atom. This is the valence shell and the orbital which is the shell which is present before this valence shell called as penultimate shell. In D block elements, both valence shell and penultimate shell orbitals are incompletely filled. This is the general condition must be satisfied by all the D block elements. As we know, S block and P block elements are usually considered as the main group elements, and these D block elements also called as a transition metals. Then what are transition elements? These are again the elements in the periodic table which are carrying incompletely filled n-1d orbitals in the atomic state or in a chemically significant oxidation state. Okay? Again I am repeating. Transition elements are the elements which are having incompletely filled n-1d orbitals in the atomic state or in the chemically significant oxidation state. As if you call the valence shell as n orbital, and we told the penultimate shell is the orbital which is present before the valence shell, nothing but here we are telling it is the n-1d orbitals. Then coming to the general electronic configuration of these D block elements, it is n-1, D 1 to 9. As we know, D can accommodate total of 10 electrons. As we told, transition elements or D block elements will have incompletely filled D shells. That's why we are taking here n-1d as 1 to 9 and ns may be 0 or it may be 1 or the completely filled condition 2 also. And next comes the question, is all D block elements or transition elements or transition metals? Most or all D block elements are known as transition elements because They occupy a transitional zone in the properties between strong electropositive metals of group 1 and 2. That is, group 1 it is alkali metals and group 2 it is alkaline earth metals, and the weakly electropositive metals of groups 13 to 16. 13 starts with the third A group, boron family, and the last group it is 16 group. Is all transition elements d block or all d block elements are transition elements? This is a very important statement. All the transition metals are d block elements, but all d block elements are not transition elements. In the periodic table, group 3 or group 11, which are counted as the d block metals, sometimes they are not counted as the transition metals because they do not show the chemical properties, characteristics of transition metals. The properties which they are not showing, they are multiple oxidation states and property of color. Nothing but this doesn't have ability to form a colored compounds. Coming to the first electronic configuration of transition elements. Here the outermost shell it is Ns and the penultimate shell it is N-1d, as we already explained. The configuration of outermost shell remains unchanged in all these d block elements, while the electron it is added continuously to the N-1d orbitals. Here the orbitals, as we know, during the filling of electrons in the orbitals which are having lower energy will be filled first, then next higher, next higher. Here if you take the first transition series or 3D series, the electrons will be first filled in the 4s orbital, then the electrons will be filled in the 3D. And the very important condition we should remember during the filling of electrons in this d block elements, it is nothing but the exactly half filled and completely filled d orbitals are extra stable. Nothing but any electronic configuration which is getting the condition of half filled, nothing but d half filled means d5, and completely filled of d it is d10. That electronic configuration gives extra stability to that element. Very good examples of 3D series. One it is Cr. Cr means chromium, and Cu. Cu means copper. Chromium has atomic number 24 and copper has atomic number 29. Let us see. For the electronic configuration production for second and third series it is difficult. Why? Because here in second and third series, that is 4D and 5D series, the electron and nuclear electron attraction play important role in determining the configuration of these members. That's why here we cannot exactly predict the electronic configuration like that of 3D series. The d block elements, whatever we have telling that this particular electronic N-1d 1 to 9 Ns 0 1 2, these d block elements are classified into total of 3 series, and each series you will have 10 elements involving the filling of 3d orbital, 4d orbital and 5d subshells. The 3d series will start from scandium and it will be ending with the zinc. 4d series will start with the yttrium, Yt, and ends with the element cadmium. And the last series, third transition series, 5d series, it will be starting with the element lanthanum, denoted by the symbol La, and ends with the mercury Hg. The elements third A, that is scandium, yttrium, lanthanum and also actinium, and the elements 2B, that is last element zinc, cadmium, mercury are referred to as non-typical transition elements, while the other transition elements, they are generally called as a typical transition elements. Electronic configuration. 3D block elements. Here, as we know, it will be starting with the elements scandium, next titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Here in this table, we have shown the electronic configuration of these elements in this atomic state, in their +2 oxidation state and also in the +3 oxidation state. Here first the 4s orbital it is filled, next the filling of electrons will take place in the 3D. As we told that there will be an extra stability for half filled and completely filled d orbitals. As the chromium has the half filled condition as argon 3d5 4s1 and copper it is 3d10 4s1. Even though we told that the prediction of electronic configuration for 4D and 5D series it is difficult, to some extent we can write the electronic configuration of these elements. This is yttrium starting element and it will be ending with cadmium, and the 5D series starts with lanthanum and ends with the mercury. Okay, this is the electronic configuration of 4D series and also 5D series. Now, once we have known the electronic configuration, we will know the general properties of these D block elements before going to its characteristic properties like variable oxidation states, magnetic properties, catalytic properties, complex formation or formation of colored compounds. For understanding of these topics, first of all, we will know the general properties of these transition elements. The first important property which we will know about it is atomic or covalent radii. As we are considering a series or periods, as we know, with increase in the atomic number along the series, the atomic radius will be decreased. Nothing but here also same, the D block elements show decrease in the atomic radius with increase in the atomic number. This decrease is not uniform across the period and this decrease is small when compared with that of S and P block elements. Why means? Due to the property screening effect. Why here the addition of electron, it is taking place into the penultimate shell, that is inner n-1d subshell, which adds a primary screening effect. That's why the decrease is not uniform and also decrease it is small when compared with that of S and P block elements. And here the atomic size doesn't alter from chromium to copper, that is from atomic number 24 to 29. And if you see the atomic radii of second and third transition series, it is very close due to lanthanide contraction. We will discuss the lanthanide contraction in the F block elements. Next important property of transition elements, it is metallic character. As we already told, I am calling transition elements as transition metals. Here all transition elements are metals and these are malleable and ductile, and this will form alloys with other metals. So many alloys are formed by combination of one of the element as a D block element. And these are good conductors of heat and electricity, one of the property of metals as we know. And coming to its bonding, here two types of bondings will be present. One is a covalent and also metallic bonding. Next property of transition elements, it is melting and boiling points. These values are generally high when compared with that of S and P block elements. Why? Due to the presence of strong metallic bonding because of overlapping between n minus 1d orbitals. Okay, due to the overlapping of n minus 1d orbitals and strong metallic bonding, their melting and boiling points are generally high. And also covalent bonding by the unpaired d electrons. These 2 points makes the d block elements to melt or to boil at higher values. And if you take the last elements of 3d, 4d and 5d, that is zinc, cadmium and mercury, these doesn't form covalent bonding. Why? Means these doesn't have any unpaired electrons, or these are all having the filled d orbitals. Nothing but these used to have a low melting point than other d block elements. Next property, atomic volume and density. This atomic volume and density values are less when compared with that of S and P block elements. Why? Here the electrons are added into the n minus 1d orbitals rather than into the fresh np orbital. Hence what happens? Nuclear charge increases, and what happens? Nuclear charge increases. This nuclear charge pulls the electrons, making the volume and density to be smaller when compared with that of S and P block elements. As the atomic volume, as we know, it decreases, the density of these elements used to increases. Okay, and as we hear, I am telling once again, atomic volume decreases, density of these elements used to increase. And the very important thing it is, transition elements we used to have very high densities. One of the element, transition element which is having high density is osmium, having the value of 22 grams per centimeter cube, and density increases across the period and it is maximum at 8th group. And if you see the density of 5d series, it is almost twice with that of 4d series. One more important property of d block elements or transition metals or elements, this ionization energy or ionization potential. What is ionization energy? It is nothing but a minimum amount of energy required to remove an electron from the outermost orbital. Here also if you see the ionization potential, since as we told that atomic radius used to decrease, here these particular transition elements used to have high ionization energies, and this ionization energies lies between S block elements and P block elements, and this IP values increases as we move across the series, and these values will be less than corresponding IP values of S block